My goal today is to walk you through my analysis of the bike's wiring diagram and the process I use to figure out how to actually install this part. And if you saw my last video on my exhaust, you know that I try to be as detailed as possible, and I really want to make sure that anyone can do this job on any bike, not necessarily a Honda CRF in my case. The first step in the process of installing this on your motorcycle is to find the wiring diagrams for your bike. Now, this can be found in the owner's manual or online. Just do a quick Google search. But here I have a couple wiring diagrams that I'm going to be walking you through today. First, let's start with the wiring diagram of my bike, the CRF250X. So the process that I followed was, number one, figuring out how the bike works, because to install an aftermarket component, you should have a very good understanding of how your electrical system works on the bike. Now, when we consider the ignition system as a general category, what I'm talking about is essentially the starter switch, the stop switch, and the clutch switch. Those are the main parts of your ignition system. So what I'm going to do first is I'm going to analyze each wire in this system to get an idea of how the voltage and current flows through the circuit during the process of starting up your bike and stopping your bike. So let's start with the clutch switch. What I'm going to do here is just trace this wire. My goal is to, again, figure out what these wires do. Okay, so this is the first wire in the clutch switch. We can see from this part of the diagram that this wire is connected directly to the main fuse and directly to the battery. So we know that this wire is always hot, or always has 12 volts. Next, this wire we see is connected to the starter switch. Looking at the engine stop switch, we see the ground symbol right here, and we know that this wire is connected to ground. And we can confirm that by looking at other parts of the schematic where this wire always appears to be going to ground. So we know where our ground node is. Next, we have the wire on the stop switch that we can see is going into the ICM, or ignition control module. And lastly, we have the starter switch wire, which is going back to the starter relay switch. So now that we have the wires in our ignition system identified, let's break down what's happening in the circuit. If we remember from earlier, the red wire is always hot, always has 12 volts. This is going into the clutch switch. When you squeeze the clutch lever, internally here, these two wires are being connected. So that means that the 12 volts is going to the purple wire, which therefore is going to the starter switch. So you might have an idea already of what's happening. You squeeze the clutch switch, that switch is closed, 12 volts goes through the clutch switch into the starter switch. Here's the starter switch. It has 12 volts just sitting here. When I press the button, that 12 volts completes the circuit and goes back through to the starter motor and energizes the starter motor. Now, when you press the stop switch, when you're done riding and you want to kill your bike, when you press the stop switch, what's happening here is, remember, this pin is always at ground. It's our ground node. When you press the stop switch, these two wires are getting connected, and the switch is pulling the ICM to ground. So now we have to understand how the bike works that this switch came from. This ignition switch is from a 2008 Honda CRF250X. So I pulled the wiring diagram for that bike, and we're going to use the same procedure here to understand how this bike works as well. We want to focus on the group that can be considered the ignition subsystem, or ignition group, however you want to call it, which contains the clutch switch, the engine stop button, the starter button, and in this case, the ignition switch. This ignition switch is this piece right here. Good practice before we dive too deep into the project. Let's verify that we have the correct part and we have the correct schematic. So we have 4 wires here. You'll notice right away that 3 of these wires are male ends, and this wire is female end. Does that match our wiring diagram? Here we have a male, 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 and female. So that's correct. What about the colors? Black, white, green, black, and red. The colors match. So we have confirmed that we have the correct part in comparison to this wiring diagram. So let's follow the same procedure now that we did for the 250X. Let's start with this wire here. This wire, we can see, is, again, connected directly to the battery through a 7.5 amp fuse. So we can say that this node is always hot or has 12 volts. This wire, notice, is connected to the starter button. So here we see this green node. And lastly, we have our black-white wire. Sorry, let me also trace this wire from the starter switch. So at this point in our analysis, we don't quite have a full picture of the circuit because we don't know what the ignition switch does. We can make a prediction and then verify through a real measurement. So looking at the diagram, we have the red wire coming directly from battery to the ignition switch. And then we see this blue wire suspiciously coming from the ignition switch to the starter button. We're not sure what the blue wire does, but my hypothesis is that inside of the switch, in the on position, the red wire and the blue wire are connected, therefore providing 12 volts from red to blue, therefore providing 12 volts to the starter button to start the bike. My second prediction is that the black wire on the engine stop button, when the key is turned off, is connected to ground. We see that the black wire comes from the stop button and goes to the ICM, the ignition control module. So if you remember what the stop button does on the other diagram, it pulls the ICM to ground when the kill switch is pressed. I suspect the same happens here. When the kill switch is pressed, the ignition control module is pulled to ground, hence killing the bike. We have to remember that on this diagram, the 230F, we have 2 kill switches. We have the stop button, the kill switch you press, the bike dies. But now we are adding an additional kill switch. When I turn the key, the bike should die also. So we see here, when the engine stop button is pressed, the ICM, the black wire, is pulled to ground. But how does this act as a kill switch also? Well, the same wire, the black wire here, must also be pulled to ground when the key is turned. Now, how exactly is that happening? My second hypothesis is that when the key is in the off position, these two pins are connected. Therefore, pulling the ICM to ground. So, now let's verify the two predictions that we've made. Right now, the key is out, so the switch is in the off position. The hypothesis is that the black-white and the green wire are shorted in the off position. These two wires, in other words, are touching each other when the key is off. These two wires are touching each other inside of this mechanism. Again, this is the prediction we're making. How do we verify that? Here I just have a standard multimeter. And I have a function on the multimeter that when these two leads are pressed together, it will make a beeping noise. Let's see if you can hear it quickly. Hopefully you can hear that, but if not, there is a beeping noise coming from the multimeter when these are pressed. So, to verify the hypothesis, I'm going to make this test here. So we've just confirmed that in the off position, these two wires are shorted internal to this mechanism. Let's confirm the other hypothesis. When the key is in the on position, the red and black wire, let's switch colors. The red and black wire are shorted when the key is in the on position. So same procedure, we're going to take our multimeter. We're going to put that in there. All right, we have just confirmed our second hypothesis that these wires are shorted. So, to recap this diagram, power is coming from the battery up through the red wire. When the key is in the on position, it's coming through the switch, down through the blue wire. You press the starter button. Current's flowing through the purple wire, back to the starter relay, energizing the starter motor. This is assuming, of course, the clutch switch is pulled in, therefore completing the circuit of the starter motor to ground. Again, I'm leaving out some details for the sake of time, but that is, in a general sense, what is happening here. Now, the question is, how do we interface these two wiring diagrams together? You know, so we have to install this part, we have to install this switch onto this diagram. Can be tricky. Let's lay out some goals, and then I'll kind of work you through my procedure. So what are the goals? The goal is that when we turn this switch on, when the switch is in the on position, you should be able to pull the clutch in, press the electric start, and the bike should start up. When the switch is in the off position, you pull the clutch in and press the electric start. The bike should not turn on because the key is off. So that's a goal. What's another goal? When the bike is turned on, you turn the key off, the bike should stop. And I'm going to show you what the conclusion is that I came to. So what I've done in this diagram is created the ignition switch in a unique symbol in this top corner. And I've taken the liberty of wiring it up and laying out the diagram in a little bit better format, just for the sake of time, really. But I'm going to go through with you guys right now how this works. So from a high level, just looking down at the diagram, we see that the ignition switch is wired in series with the clutch switch and also in parallel with the stop switch. Let's look at the red wire coming from battery, providing current to the ignition switch. There is always 12 volts sitting at this wire. It's like it's connected directly to the battery, this red wire. When the switch is on, that puts the 12 volts on the orange wire for the clutch switch. If the key is not turned on, this internal connection does not happen. Therefore, the orange wire does not have 12 volts. So, the clutch is engaged, 12 volts is applied through the switch, down through here. Now we have a 12 volt potential at the starter switch. We press the electric start. The circuit is completed up through the starter relay and the motor is energized. The bike starts. Now the procedure for killing the bike or stopping the bike, the switch is wired in parallel with the stop switch. What that means is the key stop and the button stop can happen independently of each other. Remember, you can kill the bike by turning the key off or by pressing the electronic kill switch. The stop switch, when the switch is pressed, pulls the ICM, the blue wire shown here, pulls it to ground through the dedicated ground pin. How the ignition switch works is the same. It pulls the ICM to ground, but instead of using the stop switch to complete the circuit, it uses the ignition switch here, pulls the blue pin to ground, and that is how I plan to install this switch. So, I have the connections that I need. I know the wire colors. They're listed on the diagram here. Here's the legend at the bottom. So I now, really the next step is to get down to the motorcycle, tear it apart, and install this. Okay, so what we are looking at now is the front of the bike. The headlight is removed, and I have exposed all of the wiring. We have our red wire coming from the starter relay going up to what was the clutch switch, but we're going to wire it into the ignition switch. At this point, it's just good practice to confirm our understanding. So if you remember from earlier, I said that this red wire is always hot, always has 12 volts. What I'm going to do is measure ground up at the clutch switch, and I'm going to measure voltage here, and hopefully you'll be able to see the screen that says 12.6 volts. So that has confirmed our understanding. So let's figure out what wires we'll be working with. This one, black red. This is the color designator and the legend is right here. Black red. That's the one I just measured, but here we can see that there. This one for ground is black green, and for the other kill switch, it's black white. So here we have black green, and this looks like black white next to it. So the first wire that I'm going to be working with is the power wire. Remember, this is the black and red wire that has a dedicated 12 volts always from the starter. You'll see we have the electrical connector here, so actually I can just pull that apart. So the red wire, male to female, snap in like that, and the other side will go into here. At this point, our ignition should work, and we can actually go ahead and test this right away. This circuit is connected when ignition is on, but if ignition is off, the key's out, then there should be no power going to the clutch switch. Okay, let's pull the clutch in and let's try to start it. Nothing happens. What I'm gonna do now is put the key in the ignition, turn it on, pull the clutch in. That's good news. So our on ignition, the ignition switch in the on position is working. We just confirmed that. So now the only thing left to do is wire up the ground side, the ignition off side. And remember, this is in parallel with the engine stop switch. So I'm just going to actually cut these wires. So remember, we're working with the black white and black green. So I am cutting these wires. Okay, so we got the wires mocked up. I cut the black, white, and the black green wires in half, then twisted them back together. And what this is effectively doing is wiring the ignition switch in parallel. So these two wires will connect right here. So what I'm gonna do now is set up my soldering equipment. Oh, by the way, you should always wear safety glasses when you're soldering. So yeah, those are done. What I'm gonna do is tape these up now and then wire the switch in to the other side. The two wires that I installed here do not have connections to mate up with this. What I'm gonna do is just cut these off. It's not that important for me. And just to give myself a little bit more space to work with, I'm gonna cut back, just will expose a little bit more of the wiring to work with. Next, let's go ahead and strip these off. So let's wire back up the starter circuit because I did unplug that to solder up the other connections. Just gonna connect these two wires. When I tried to start the bike, actually it didn't work. My mistakes: never work on electrical systems without disconnecting the battery first. So I did not disconnect the battery, and some of these wires must have touched each other while I was working, because there appeared to be a short, and my main fuse on the bike, my main fuse blew. So that's why it didn't start when I expected it to. But I did get that fuse pulled and replaced. It took me a little bit. I forgot to record it, but now it's working okay. It's all wired up, and I taped all the wires together. I'm not going to mount the switch right now because I will probably 3D print a mount at another time, so I'm not going to show that in this video. Let me give you guys a video of the switch working correctly, just so you believe me that it does in fact work. So right now we're in the on position. Well, let's start in the off position. Let's try to start the bike. So the bike does not start because the key is in the off position. Now the key's on. Let's try to kill the bike with the key. So everything does appear to be working correctly. Again, I'm gonna organize all this and put this back on and mount this at a later time. I can probably make a quick video just updating you guys where I mount this, but for now, this is how you install an ignition switch on your motorcycle. If you have any questions, please leave a comment. Thank you for watching. Have a good one.